Welcome to my class. We continue on elastic properties of solid. In my past video, we discussed about some concepts related to elastic properties of solid, such as Hooke's law, the strain, the stress, and the Young modulus. So today's class will be based on calculation on Hooke's law. So let's have the first question on Hooke's law. If a force of 50 Newton stretches a wire from 20 meter to 20.01 meter, what is the amount of the force required to stretch the same material from 20 meter to 20.05 meter? So when you see a question like this, the first thing to do is to write your parameters out. So let's bring out our parameter. If a force of 50 Newton, that is F equal to 50 Newton, stretches a wire from 20 meter to 20.01 meter. So it shows that the original length of the wire equal to 20 meter. So let's call it L1 equal to 20 meter. Then the wire stretches to 20.01 meter. That will be the final length of the wire. So let's call it L2 equal to 20.01 meter. So what is the amount of the force that will be required to stretch the same material? We are looking for the amount of force that will be required to stretch the same material from 20 meter to 20.05 meter. So we are looking for the amount of force. So let's call it F2 and call this one F1. So we are looking for the amount of force that will stretch the wire from 20 meter to 20.05 meter. So for the second force, our L1, which is the original length, equal to 20 meter. Then the final length, L2, will be equal to 20.05 meter. Now, according to Hooke's law states that the force applied on an elastic material is directly proportional to the extension. So therefore, F directly proportional to E. So F equal to, our sign of proportionality will change to constant K. So constant K E. So K is our force constant. K is force constant. Then E is our extension. So to calculate extension equal to change in length. That is the final length minus the original length. So for the first one, let's calculate our change in length. Let's calculate the change in length. So let's call it E1. E1 equal to, so the final length equal to 20.01. 20.01 minus the original length, which is L1, that is 20. So our E1 will be equal to 20.01 minus 20 will give us 0.01 meter. So therefore, we can apply now. So our F1, so from F equal to KE. So we can make K the subject of the formula. Since we have our F and we have gotten the value of E, so let's make K the subject of the formula. So K will be equal to force divided by extension. So therefore, our K will now be equal to, so what is force? Our F1 equal to 50. So that will be 50 divided by, so extension E, that is E1. What is extension E? That is 0.01. So divided by 0.01. So our constant K will be equal to 50 divided by 0.01 will give us 500. So 500 watts. So what is the unit? Our force is in Newton. So Newton, then extension is in meter. So we call this Newton per meter. Newton per meter. So we are looking for F2. So we have to look for E2, that is the extension 2. So for F2, when F2 equal to unknown, then extension 2 will be equal to, so the change in length, that will be L2 minus L1. L2 minus L1. So which is equal to our L2 for extension 2 equal to 20.05. So 20.05 minus the original length equal to 20 minus 20. So extension 2 will be equal to 20.05 minus 20 will give us 0.05 meter. So that is E2. Now to calculate F2, so our F will be equal to KE. So for F2 is unknown, that will be F equal to, what is our constant? K. So K is a constant value, it won't change. So that is 5,000. 5,000 multiplied by extension 2, which is E2. So 0.05 multiplied by 0.05. So which is equal to 5,000 times 0.05 will give us 250. So 250 watts. F is in what? Is in Newton. So 250 Newton. So the correct answer is option C. Let's have question 2 on Hooke's law. A spiral spring extends from a length of 10.00 centimeter to 10.01 centimeter. The original length of the spring is 10 centimeter. So we call it L1. 10.00 centimeter. So the spring extends to 10.01 centimeter. So we call it L2. 10.01 centimeter. When a force of 20 Newton is applied, so that is our F equal to 20 Newton. So calculate the force constant of the spring. According to Hooke's law, force is directly proportional to extension. So therefore, F will be equal to, this sign of proportionality will change to constant K. So that is KE. So this K is what? Is our force constant. So K is our force constant. So therefore, K is what? Is unknown. We are looking for K. So we are going to make K the subject of the formula from F equal to KE. So from F equal to KE, so K will be equal to force divided by extension E. So from our parameter now, there is nothing like extension E. But extension E is the same thing as change in length. That is L2 minus L1. The final length minus the original length. So our final length here is 10.01. 10.01 centimeter minus 10.00. 10.00 centimeter equal to, so 10.01 minus 10.00 will give us 0.01 centimeter. So we have to convert this is 0.01 centimeter to meter because our extension E must be in meter. So therefore, E will be equal to 0.01 centimeter divided by 100. So to convert it to meter, so it will give us 0.0001 meter. So we have converted 0.01 centimeter to meter. So we go back to the formula. We are looking for constant K. We are looking for K. So K equal to force divided by extension E. So F divided by E. So K will be equal to, then what is the value of F? What is F? Our F equal to 20 Newton. F equal to 20 Newton. So that will be 20 divided by, so our extension E equal to 0.001. 0.0001. So which is equal to 200,000. 200,000. So we can convert it to standard form. So our K will be equal to 2 times 10 raised to power 1, 2, 3, 4, 5. 10 raised to power 5. Then what is the unit for constant K? Our force is in Newton. So that will be Newton per, then extension E is in meter. So Newton per meter. So this is the final answer. So let's move to question 3. The third question. The total length of a spring when a mass of 20 grams is on from its end is 14 centimeter. while its total length is 16 centimeter when a mass of 30 grams is hung from the same end. Calculate the unstretched length of the spring, assuming Hooke's law is obeyed. We are looking for the unstretched length of the spring. So the unstretched length of the spring is the original length of the spring. Then we should not forget that spring is an example of elastic material. So let's assume that this is the original spring, but we don't know the length of the spring. So let's call the length of the original spring L1. So when a mass of 20 grams was hung on it, the length increased to 14 centimeters. So automatically the length will come down. So the length will come down when a mass of 20 grams was hung on it. So the length increased to 14 centimeters. So the total length now is 14 centimeters. So when its total length increased to 16, the total length increased to 16 when a mass of 30 grams was hung on the same spring, on that same spring. So let's do another diagram for the second statement. So the same spring with an unknown length. So we don't know the length of that same spring. So when a mass of 30 grams was hung on it, when a mass of 30 grams was hung on it, automatically the length will increase. The length will increase. So the length increased to 16 centimeters. Now the second diagram, now for the second diagram, the total length will be 16 centimeters. 16 centimeters. So we are looking for the what? The original length, which is L1. Assuming Hooke's law is obeyed, then what is Hooke's law? Hooke's law states that the force applied on an elastic material is directly proportional to the extension. So therefore, force will be equal to, the sign of proportionality will change to constant K. So KE. So this E is an extension. Then what is extension? Increase in length or change in length of an elastic material. Then where do we have increase in length? That is from here. So the original length stopped at this point. So increase in length is from here down to this place. So this is our extension from the first diagram. So for the second diagram, this is our extension, which is the same thing as change in length. So extension equal to the final length minus the original length. The final length minus the original length. So let's replace our E with L2 minus L1. So our equation will now be F equal to K into bracket. So E equal to L2 minus L1. L2 minus L1. So for the first diagram, so our force equal to 20 grams is the same thing as mass. So 20 equal to K is unknown into bracket. So L2 is the final length. So the final length equal to 14 centimeters. So 14 minus the original length is unknown. So the original length of the spring is L1 minus L1. So that is, let's call this one equation 1. Then for the second diagram, our mass, which is the same thing as force, is equal to what? 30. So 30 equal to constant K into bracket. The final length, the total length equal to 16. So that is 16 minus the original length. We don't know the original length of the spring. So that is 16 minus L1. So let's call this one equation 2. Equation 2. So from equation 1, let's make K the subject of the formula. Let's make K the subject of the formula. So K will be equal to 20 divided by 14 minus L1. K equal to 20 divided by 14 minus L1. From this equation 1. So from equation 2, to calculate K will be equal to 30 divided by 16 minus L1. 30 divided by 16 minus L1. So K equal to K. So let's K here be equal to this K. So therefore, 20 divided by 14 minus L1 equal to 30 divided by 16 minus L1. Since constant is constant, so constant is constant, so K equal to K, then we cross multiply. So by the time we cross multiply, we are going to have 30 into bracket 14 minus L1. 14 minus L1 equal to 20 multiplied by 16 minus L1. So 20 into bracket 16 minus L1. So let's open the bracket. 30 times 14 will give us 420. 30 times L will give us 30 L1. Then equal to 20 times 16, that will be 320. Minus 20 times L1 will give us 20 L1. So let's collect the like terms. 420 minus 320 will be equal to minus 20 L1. So bring minus 30 to this place will give us plus 30 L1. So 420 minus 320 will give us 100 equal to minus 20 L1 plus 30 L1 will give us 10 L1. So we are looking for the value of L1. So we divide both sides by 10. So divided by 10. Divided by 10. So 10 cancel 10. So our L1 equal to 100 divided by 10 will give us 10. So the value of L is equal to 10. 10 what? It should be in centimeter. 10 centimeter. So the length of the unstretched spring equal to 10 centimeter. So the correct answer is